Hey everyone, Shivani here. Today we're solving one of the biggest challenges in machine learning. How do you actually choose the right algorithm? It's often the hardest part of any project. With over 50 options to navigate and a sea of complex terminology like linear, logistic, and random forest, it's easy to feel overwhelmed. Making the wrong choice can waste valuable time and resources. But don't worry, today we'll break down the process and make it simple. By the end of this video, you'll have a clear path to selecting the best algorithm for your needs, no matter your experience level. Very first question to ask is, do you have labeled data? This is the foundation for your decision. Labeled data means you have both the input features and the correct answers, like house features with their prices. If you only have raw inputs, such as customer behavior with no known outcomes, your data is unlabeled. This distinction will guide you down the right path and help you avoid confusion later on. Let's clarify the difference. Labeled data includes both your inputs and the target answers. For example, you might have a dataset of houses with their features and their selling prices. Unlabeled data, on the other hand, includes only the inputs. Think of customer behavior logs with no information about the outcome. Knowing which type you have is crucial, as it determines whether you'll use supervised or unsupervised learning. Once you know if your data is labeled or not, you can choose between two core paths, supervised learning and unsupervised learning. Supervised learning is used when you have labeled data and want to predict known outcomes. Unsupervised learning is for discovering hidden structures in data without labels. This split is the first big decision in your algorithm selection journey. Supervised learning is all about using historical labeled data to predict known targets. For example, you might want to predict house prices based on past sales or classify emails as spam or not spam. The key is that you already know the correct answers for your training data, which allows the algorithm to learn from examples. Unsupervised learning is used when you have no target answers, just raw data. The goal here is to discover hidden structures, patterns, or groupings within your data. For instance, you might want to segment customers into different groups based on their behavior, even though you don't know the right groupings ahead of time. If you're using supervised learning, the next question is, are you predicting numbers or categories? This distinction helps you choose between regression and classification algorithms. Predicting a continuous value, like price or temperature, calls for regression. If you're sorting data into categories, like spam versus not spam, you'll need classification. Regression algorithms are used when your goal is to predict continuous numerical values. Think about predicting house prices, stock values, or temperatures. These algorithms learn from historical data to estimate future values. They're perfect for any scenario where your answer is a number, not a category. Classification algorithms help you predict discrete classes or categories. For example, you might want to classify emails as spam or not spam, or detect fraudulent transactions. These algorithms are designed to sort data into groups, making them ideal for tasks where the answer is a label, not a number. Let's look at some common regression algorithms. Linear regression is great for simple trends and baseline models. Random forest regressor handles complex data with many features. Decision tree regressor is useful when you want interpretable, rule-based logic. And neural networks shine when you have large datasets with high complexity. Each has its strengths, so match the algorithm to your data's needs. When it comes to classification, you need to know if your problem is binary, meaning two classes, or multiclass, which involves more than two categories. For binary problems, logistic regression and SVM are popular choices. For multiclass or more complex scenarios, consider random forest, naive Bayes, k-nearest neighbors, or neural networks. If you're working with unlabeled data, your next step is to define your goal. Are you trying to group similar items together, reduce the number of features, or visualize complex data? Your objective will determine which unsupervised algorithm to use, so take a moment to clarify what you want to achieve. Clustering is a common unsupervised learning task. K-means is fast and efficient when you know the number of groups ahead of time. DBSCAN is great for handling noise and clusters of arbitrary shapes. Hierarchical clustering helps you visualize relationships through tree-like dendrograms. Each method has its own strengths, so choose based on your data and goals. K-means is one of the most popular clustering algorithms. It's fast and works well when you know how many groups you want to find. The algorithm assigns each data point to the nearest group center, making it easy to understand and implement. It's a great starting point for many clustering tasks. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. It's especially useful when your data has clusters of different shapes and sizes, or when there's noise. Unlike K-means, you don't need to specify the number of clusters in advance. DBSCAN can find clusters and mark outliers automatically. Hierarchical clustering builds a tree of clusters, called a dendrogram. This method helps you see how data points are related at different levels of similarity. It's especially useful for visualizing complex relationships and doesn't require you to choose the number of clusters up front. Sometimes your data has too many features, making it hard to analyze or visualize. Dimensionality reduction techniques, like t-SNE or PCA, help you simplify your data while keeping the important patterns. These methods are great for visualizing high-dimensional data or speeding up other algorithms. Make things even easier, use a decision tree or quick selection guide. Start by defining your objective. Do you want to predict a value, categorize data, achieve high accuracy, map segments, visualize data, or analyze text? Each goal points you to a recommended starting algorithm, making the selection process much more straightforward. Here's a quick guide. If your goal is to predict a value, start with linear regression. To categorize data, try logistic regression. For high accuracy, random forest is a solid choice. If you want to map segments, use k-means. For visualizing data, t-SNE is helpful. And for analyzing text, naive Bayes is a go-to algorithm. This cheat sheet can save you time and effort. Before you make your final choice, here are 3 actionable tips. First, always start simple. Begin with basic algorithms and only move to complex ones if needed. Second, validate your results using cross-validation or holdout sets. Third, don't be afraid to experiment. Sometimes, the best algorithm is found through trial and error. These tips will help you avoid common pitfalls and make smarter decisions. Choosing the right machine learning algorithm doesn't have to be overwhelming. By breaking down the process into clear steps, starting with your data, defining your goal, and matching it to the right algorithm, you can make confident, informed decisions. Remember, start simple, validate your results, and keep experimenting. With this approach, you'll be well on your way to successful machine learning projects. If this video helped you, hit that like button and subscribe to Shivani Works for more data science content that actually makes sense. Thanks for watching, and I'll see you in the next video.